Linear differential equation. It is of the form dy dx plus py is equal to q, where p and q are functions of x. Means what? This dy dx, it is first order differential coefficient. Its independent variable is y, and y depends on x. So we are taking derivative with respect to x, and this p and q, they are function of x, and this is y. Y is the dependent variable. So, or if we say dx dy, then x is our dependent variable, y is independent variable, p and q are function of y, this independent variable, and x is the dependent variable. X depends on y. So any one of this form, or we can change this variable. We can write z for y also. Then this, if we write z for y, then we will write here z in place of y. So like this. Now there is an algorithm for solving linear equation. So linear equation is, we say this e to the power integration p dx, this part, e to the power integration p dx, this we say as integrating factor. Integration of p dx, this p is coefficient of y, so integration of p dx, this is integrating factor, we say. Then this is integrating factor. So step 1 is, first we find integrating factor, then solution is y into integrating factor is equal to integration of q is the right part, this part, right part, and then q into integrating factor dx plus c. And this is, its logic is this one. If we take derivative of y into e to the power integration p dx, y into integrating factor, then this is the, we have this one dy dx, then it is product of y and integrating factor. So y is this dy dx, then into this part, second part, then y is the first part, then derivative of this is e to the power integration p dx is p into e to the power p dx, and we have this dy dx plus py. So this is equal to, so if we integrate this d dx of this, then this with respect to x we integrate this, then our result is y into e to the power p dx is equal to q into, this is q, so q into e to the power integration p dx. So this is the solution. So just we have to remember this. Step 1 find integrating factor, step 2 solution is this, and linear equation. So solution is y into integrating factor is equal to this one. So this is the solution. Then another form is here. If we say this part, if we say x is dependent variable, it depends on y is independent variable, then it will be our x into integrating factor, then our integrating factor will be e to the power integration p dy, then x into integrating factor is equal to integration of q into integrating factor, and this with respect to dy. So let us see some example. So x dy dx minus 3y is equal to x square. So if we write dy dx, means what we are dividing by x, then what we get, dy dx plus coefficient of y is minus 3, then we are dividing by x, and y is equal to, right hand side we are divide by y, x, this coefficient, so it is x square by x, it is x. Now we see dy dx, so our p is this coefficient of y minus 3 by x, so our integrating factor is e to the power integration minus 3 by x dx, then integration of 1 by x is log x, minus 3 is a coefficient, so e to the power it is e to the power minus 3 log x, and e to the power minus 3 log x means x to the power minus 3. So solution is y into indicating factor. So indicating factor is x to the power minus 3, then is equal to q is x, this is q, this is q is x, then x to the power minus 3 is indicating factor, then dx, then it is x to the power minus 2. So x to the power minus 2 means 1 by x square, so this is 1 by x square, then integrate it, after integration it is minus 1 by x. So this is our solution. So it is y, then minus x to the power minus 2 we are multiplying by x cube, then it is, this is y, then and right hand side is minus x square plus cx cube. So this is a solution. In number 2, what do you have? dy dx, then p is here minus 1, p is minus 1, and q is x into e to the power x, it is function of x, so this is q. So indicating factor is e to the power minus 1 integration of e to the power integration of minus 1 dx, p is here minus 1, so it is e to the power minus x. So solution is now y into e to the power minus x is equal to integration of x e to the power x, this is q, then indicating factor is e to the power minus x dx, then after product e to the power x into e to the power minus x, this is 1, x minus x, it is 0, so e to the power 0 is 1, so remains x only, so x dx, and integration of x is x square by 2, so this is the solution. So it is y to the power minus y into e to the power minus x is equal to x square by 2 plus c, or if we remove this one, means we have to multiply by e to the power x, then it is y, and right hand side is x square by 2 into plus c into e to the power x. So this is the solution. Similarly, this problem, this is the problem. So q here is 2x square, p is minus 1 by x, so minus 1 by x integration is minus log x, then it is e to the power minus log x, e to the power log x is x, then minus 1 is the power of this, so it is x to the power minus 1, and solution is y into x to the power minus 1, then integrate it, it is twice x dx, it is x square plus c, and so you multiply by x now to remove this x to the power minus 1, so it is y is equal to this is 1, and here it is multiply by x, so it is x cube plus cx. So same procedure, this is, and this number 6 we see, number 6 we see dy dx is equal to minus tan x is equal to sin x. So here p is coefficient of y, it is minus tan x, so integrating factor is e to the power minus integration of minus tan x, and it is minus log sec x, or log of 1 by sec x, or log of cos x, so e and log goes, remains cos x. Now its solution is now y cos x, y into integrating factor is equal to sin x cos x, so sin x is q multiplied by cos x, and this is sin x, its integration is sin square x by 2 plus c. Now we are given this condition, y0 is equal to 1. Now put x equal to 0. y0 means y is function of x, and we can put x equal to 0. If we put x equal to 0, then y is equal to 1, means we have to put x equal to 0 and y is equal to 1. So left hand side is x is 0 means it is 1, y is 1, so it is left hand side is 1, and right hand side is x is 0 means it is 0, remains c, so 0 plus c means what? C is equal to 1. So we are getting the value of c, the constant. So it is not arbitrary constant, it is a fixed value. So now we write solution is y cos x is equal to sin square x by 2 plus 1. In place of c we are writing 1. This is also similar problem, number 7. So solution is we are having in terms of c, then y1 is equal to 2 means what? We write x equal to 1 and y is equal to 2. So here x equal to 1 is 1 cube, it is y is equal to 2 into 1, and right hand side is 1 square, it is 1 plus c, so c is equal to 1. So solution is yx cube is equal to x square plus 1. In place of c we are writing 1. Then this one, this is here in this problem we see y is independent variable, so we are writing dx dy. So after simplifying this we are getting this dx dy. So dx dy means p is function of y and q is function of y. So this is function of y, so it is coefficient of x, so it is minus 2 by y, it is p. So this is our solution. Number 9 is same. Then similar problems. Then equation reducible to linear form. So it is Bernoulli's equation. We say it is this form we say is as Bernoulli's equation. So dy dx is py equal to q. We got it. But now it is y to the power n. Right hand side is y to the power n. So this y to the power n, if we make it free from y, so we are dividing by y to the power n, then right hand side is q only. Then this y, in place of y we write 1 by y to the power n minus 1, because we are dividing by y to the power n, and this is y to the power n. Now we put, so substitution is there. Now let us see this substitution. So our substitution is, let 1 by y to the power n minus 1 is equal to phi. Then dv dx means we are taking derivative of this left hand side with respect to x. So this implies ddx of y to the power n minus 1, and it is minus, coefficient is power is minus n minus 1, then y to the power minus n minus 1 minus 1 into dy dx. So left hand side is this and right hand side is dv dx. Now we have y to the power minus n plus 1 minus 1 means y to the power minus n. So you write minus n minus 1, then 1 by y to the power n dy dx. So this is minus n plus 1 minus 1, so it is minus n, so it is 1 by y to the power n, and this is equal to dv dx. So this 1 by y to the power n dy dx we write this as dv dx, and this we need to remove this one from left hand side, so we divide by this dv dx into 1 by 1 minus n. So we can write 1 by y to the power n dy dx is equal to 1 by 1 minus n dv dx. Now so this equation we write 1 by 1 minus n dv dx plus p into 1 by y to the power n minus 1 is equal to q. 1 by this is phi, so it is pv. but this is here, so we remove this. So you can write dv dx is equal to plus 1 minus n into p v is equal to 1 minus n into q. So this is our new p and this is our new q. So we can write this as p dash, or we can write, so this implies dv dx plus some p dash into v equal to q dash, where p dash we write as p into 1 minus n and q dash. So this is our new p and this is our new q. So let us see this example. So here dy dx plus y by x is equal to, so x square, so this is q and this is y to the power n. So n is 6 here. So what we will do now, we are dividing by just like this, 1 by y to the power n. So it is 1 by y to the power 6 dy dx plus 1 by x into y to the power 5 is equal to x square. So we are putting 1 by y to the power 5 as v. So 1 by 5, this is v, then dv dx is this one. Then transform linear equation is, in place of dy dx we write minus 1 by 5 dv dx plus 1 by xv is equal to x square. So our new p is minus 5 by x and new q is minus 5x square. Now it is reduced to linear equation, so we can follow this. So this is p, so indicating factor is e to the power integration minus 5 by x dx, and it is 1 by x to the power 5, and solution is this one. Now after getting this solution, we are, because we are getting this in terms of v, so in place of v we need to write 1 by y to the power 5. So this is the solution. This we see now, dy dx, so this you write as dx dy. So y is independent variable, x is dependent variable. So we are substituting 1 by x square as v, 1 by x as v, this one minus 1 by x as v, then dv dy. So it is 1 by x square dx dy, like this. So this is the solution. In terms of v and j, do we get e to the power y square by 2. So to simplify this equation, we write this as z. So this is e to the power z. Again we substitute z and v for y and x. So these are same one. You can do it and work it out, and you can understand this. Same. So these are reducible to linear equation. Next, so these are some exercise. You can try it. Next is exact equation. Exact equation, it is of the form m dx plus n dy, where m dx plus n dy equal to 0. M is mxy, function of x and y, n is function of x and y, and because it is function of two variables, we need to find partial derivative, del m del y, del n del x. So if del m del y and del n del x are equal, then we say it is an exact equation. and solution is, this is the algorithm. So integration of m dx and terms plus integration the terms free from x in n with respect to y. Or if we integrate n dy n with respect to y, then we need to find the terms in m which are free from y, and with respect to x we integrate. So this is an example. So dx coefficient is m, dx dy, sorry, this is m x cube. So this m we are writing, so m dx, this is dy, sorry, this is dy, this is dy. So m is x cube plus xy square minus s square x, and n is coefficient of dy, it is x square y minus y cube minus b square y. So with respect to y we take it the derivative, so this is 0, this is twice yx, and this is 0, and here it is with respect to x, so it is twice xy, this is 0, this is 0. So del m del y is equal to del n del x, it's satisfied, so the equation is exact. Then solution is integration of m dx, so m is this, then free from x, so free from x is this part, minus y cube minus yb square. So we can't write x square y because it is not free from x, only we are writing minus y cube and minus yb square. So this is minus y cube minus yb square with respect to y. So this is x cube, it is x to the power 4 by 4, xy square with respect to x only we are doing, so this y square it is kept as it is, so this is y square, we are taking the integration of x is x square by 2. Then s square is kept as well as usual, then x integration of x is x square by 2, this is minus sign, this is minus y to the power 4 by 4 minus y square b square by 2, so this is equal to constant. So this is the solution of the exact, very simple, only we have to find this condition if it happens or not. So this is m is this one, n is minus twice x, so because our format is this m dx plus n dy, so this equation is what, x minus twice y minus 7 dx, then plus, we need to have plus sign, so this is minus twice x plus 4y minus 5, it is dy is equal to 0. So n is this one, minus twice x plus 4y minus 5, and m is x minus twice y minus 7. So with respect to y it is, this is 0, this is 0, so it is minus 2, and with respect to x it is minus 2, this is 0, this is 0, so they are same, equal, and we apply this form. Very simple. Then number 3, same procedure, this one, just test it, find m, find n, right hand side must be 0, it can't be other value, only 0 is acceptable. So these are some examples of exact equation. This exact equation, this is. So these are examples. Do it and practice it, and you can understand. So next after exact equation, after exact equation we go to differential equation of first order and higher degree. So this differential equation contains higher degree of dy dx. So we write it is first order, no d2y dx, no d3y dx3, etc., etc. Only dy dx will occur, and we write it as p, but degree is more than 1, higher degree. So that is why we write dy dx is equal to p. So it is xy dy dx is equal to 0. So or you can write xy p. So sometimes we can factorize this equation as p minus r1, p minus r2, etc. In terms, it is because it is higher degree, because it is of higher degree, we can have this factor sometimes, and if we can have this factor, then we factorize this, then this factor we make it equal to 0. So we can write p minus r1 equal to 0. So p minus r1 means what? R1 is function of x and y, and p is dy dx. So we get a linear equation, and we can solve it. Sometimes we cannot do it, and then some these cases may arise. So equation solvable for x and equation solvable for y. And another form is Clairaut's equation. So we'll discuss this. So p square minus 4x to the power 4. So p square, so p is equal to plus minus 2x square. We are taking the square root. So we get two equations, and we can solve it. So dy dx, it is variables are separated. So dy dx is equal to 2x square, means dy is equal to 2x square into dx. dy is this, and we are solving it. So our solution is integration of dy is y plus c, and integration of x square is x cubed by 3. So this is the solution. This one we see, this is also factorizable. So we are factorizing this, we are having these two factors. It is second degree, so it is p minus twice x into p minus y square. So we are writing p minus twice x equal to 0, means dy dx is equal to twice x, and its solution is y is equal to x square plus c1. Because we are having more than one equation, so we write the constant as c1, c2, etc. So this is one solution. For this part, p equal to y square or dy dx equal to y square, then its solution is dy by y square equal to dx. It is variable separated. It is x plus 1 by y. This is equal to c2. Then solution is product of these two. So this into this, y minus x square minus c1, this is the first solution. xy minus y c2 plus 1, this is the second solution, and take the product, and this is the solution of this equation. Then this is also factorizable like this. So we get two equations, two linear equations. Let us see how we can solve it. So first one is dy 2yp is plus x equal to 0. So this, in place of p we are writing dy dx. So 2y dy dx plus x equal to 0. Then variable separated. So 2y dy is equal to x dx. So this is 2y dx. This is 2y dy plus x dx is equal to 0. So solution is, it is variables are separated. So solution is integration of 2y dy plus integration of x dx is equal to c1 we write. So twice y integration is y square, x integration is x square by 2 plus c1. This is c1 equal to 0. Then second equation is 2yp plus 3x square. So it is 2yp again 2y dy equal to 3 dy by dx. So this is now we'll have 2y dy plus 3x square dx is equal to 0. So solution is, this is integration of 2y dy plus integration of 3x square dx plus c2 is equal to c2. So this is y square, this is x cube, and this c2. So y square plus x cube plus c2 equal to 0. And this first solution, this is second solution, and their product is the general solution. Then this one, p minus 3 into p minus 4. So p minus 3 equal to 0. So dy dx is minus 3 equal to 0. So it is y minus 3x plus c1. So same procedure. So their product is this. Then x square is equal to 1 plus p square. So p you write root over x square minus 1. So dy is root over x square minus 1 into dx. And integration is integration of, so solution is integration of dy is equal to integration of root over x square minus 1 dx. So this integration is this part, this integration is this one, x by 2 into root over x square minus 1 minus half log of this one. So this is the solution. So we are taking only positive sign. We can write the negative we can write the negative sign also. P plus minus we can write. Then we will have two forms. So p plus, so it is, we will have, then this is positive we can write, or we can write negative also, because it is, this part is so if we write this part is, say this part, say it is, say f1x. If you can write f1x, then we can write solution as y equal to f1x plus c, plus minus you can write, because you can write plus minus here. P is equal to plus minus root over x square minus 1. Then we can do this y plus this as plus c1, or into y minus this and this. You can write this as c2, but not necessarily. So this will do. Then next is same procedure. So p is root over this. So p is dy dx. So dy this dx coefficient is this now, root over 1 minus x dx now. So then solution is integration of dy is y, then integration of this one, and for this we need some substitution. X is equal to cos square t we substitute, then it is cos square t, then this becomes sin t, then this becomes cos t, and dx is now 2 cos t sin t dt, minus is this. So this is cos t, denominator is sin, numerator is sin t, denominator is cos t, then it is 2 sin t cos t, so it is tan t. So to integration is now, so to this is tan t means this tan t is, I can do it as sin t by cos t, sin t by cos t. Then this cos t and this cos t goes, remains only sin t into sin t, so it is sin square t. So 2 sin square t, 2 sin square t is cos twice t minus 1. After integration we have half of sin twice t minus t plus constant. So this is the then t we write now. T is cos inverse of root over x. So these are the factorizable when it is solvable for p. So we are higher power, we are factorizing this, we are having equations, linear equations in x and y, and we are solving it and taking the product. This dy dx, we are writing p, this is 1 by p, dx dy means it is 1 by dy dx, so it is 1 by p, so p minus 1 by p, then we have this equation, then multiply this. Now we are getting second degree equation in p, factorizing it. So these are the solution. These are simple, it is simple. Then p square plus 2px minus 3x square is equal to 0. P minus x into p plus thrice x. So this is simple. Then solvable for y. So p is not factorizable here. Then what we do? We write left hand side only y, and right hand side there will be p and x. So now we take derivative. So if we take dy dx, then this becomes p. Means what? This, after taking derivative, this becomes function of x and p only. No y is here. So y, first we are getting y as this, then we take the derivative, then we have this in terms of p and x. Now we have this one derivative dp dx. Because we are taking derivative with respect to x, this we can write as p, and we need to take derivative of x and p with respect to x. So with respect to x it is 1, and with respect to p we need to write dp dx. And then we have this type of equation, and then we have these equations as linear equation in x and p. So we solve it as linear equation. So we take p as independent variable, or sometimes dependent variables also we can write. So so this is dx dp, and dx dp we are having this as linear equation. So p is independent variable, x depends on p. Like linear equation, we are solving it. So we have this in terms of x. So what we are having, x is like this, and x is in terms of p, and y is this y. So this x we write in terms of, because we are having x as function of p, and then this y we already have it, x by p minus 4p. So this x we write this value. So what we have, x as function of p, y as function of p, and this parametric equation in p. So this is the procedure. So same thing, dx dy dx, this is p, this is dx, it is function of, so we integrate it. We are having is as solution is x is in terms of p. Then put the value of x here. So this is function of p, this is function of p, so y is function of p. So it is parametric equation in p. So y is function of p, x is function of p, so this is parametric equation in p. So this is the procedure of finding this. So for solvable for y, solvable for x, so sometimes it is written as function of x, left hand side is y. So this is writing, this we are writing left hand side is y only, here we write left hand side is x only. Same procedure. So x and y are now functions of p, so they are parametric equation in p. So we have this solution as this. So these are the functions. Then Clairaut's equation. Clairaut's equation is of this form. It is very simple. It is y is equal to px minus fp, and its solution is y is equal to cx minus f. So as soon as you see this type of equation, you just write c in place of p. So this is Clairaut's equation, px minus, so px, then it is function of p, ap and p square, no x no y, only p is here. So just right, this is cx and this is as it is. So these are Clairaut's equation. This px minus y, so you eliminate log. If we eliminate log, we take exponential power. So e to the power p is equal to, e and log will go, remains px minus y. So e to the power p is equal to px minus y, then y is equal to, take y to left hand side, e to the power p to right hand side, so it is px minus px minus y e to the power p. So this is minus, this is minus, this is minus, so this is minus. Solution is this one. So these are Clairaut's equation. Okay, next we will discuss linear differential equation of higher order with constant coefficient.